All right, so let's talk about the conditional and iterations. And these are two of the most important things in programming. You want to make decisions and you also want to iterate over many values to do something again and again and again. So computers are good at doing repeated things, and that's why we like computers. So let's talk about some of the basic ideas, and then I'm going to show you how you convert those ideas into Ruby code. All right, so let's start with conditionals. And the basic idea of conditional is that we have a construct in Ruby or many languages called the if statement. An if statement take a Boolean condition that is a condition either true or false, and then if it's true, it's going to do this. Now in this particular example, we don't really talk about what happens if it's false, but we only care about what happens if it's true. Like for example, you can write if x is greater than 3, then print x, and this is the end of the statement. Now in this case, what we try to do is we take x and compare it to 3. If it's more than 3, we print it, but if it's less than or equal to 3, we don't define what we're going to do. So that's one type of a conditional statement that deals with just the true condition. So we can use that to write a function that determines if a number is even and is also a multiple of 5. So how do we think about this? First of all, when you take a number like n, if it's even, what that means is it is divisible by 2. So in programming, you have this modulo operator, and if you take the n mod 2, if it's equal to 0, then we know that the number is even. Now how do we know that number is a multiple of 5? Well, we do the same thing. We take the number and then we take mod 5. If it happens to be 0, then it is a multiple of 5. So for example, if you take 5 mod 5 is 0, 10 mod 5 is 0, 15 mod 5 is 0. So any number that's a multiple of 5, mod 5 is 0. So we convert this idea into a function like this. Define, let's call this function check. We are checking this number n, and the way we are checking the number is to say, okay, let's take a look at the n mod 2. If it's equal to 0, we know that the number is even, but that's not enough. So we have to connect these Boolean condition using and check if n mod 5 is 0. And so if you have both conditions true, then we want to return, so let's say we return true. Okay, so in order for this to be true, we must have both conditions, n mod 2 equals 0 and n mod 5 equals 0. Now, this is the end of the if statement, and we can always say something like this. We can say, yes, so let's go with this. So that's the end of the if statement, and if this condition did not become true, then we must return false. Now this is the end of the function. Now if you try to look at the semantics of this function, the function comes in, takes an n, check these two conditions. If those conditions are true, it's going to go here and return true. If those conditions are false, it's going to go here and return false. So a function can only return one value, either true or false. So this is an example where you can have more than one return statement inside a function. But once you return from a function, what that means is leave the function. So you're returning from the function based on some condition. If condition is true, you're going to leave the function. So keep that in mind. You can have multiple return statements, but only one can execute. Once you do one, the other one doesn't matter. Now we also have more detailed statements like if condition true. So if it's true, we're going to do this. And if it's false, we're going to do this. And so we can show that with a flowchart like this. If the condition is true, you're going to do 1. If the condition is false, you're going to do 2. Now, write a function to find the max of 3 numbers. Now, this can be done. If you have a function to find the max of 2 numbers, you can do this. So the best thing to do is that we'll write a function to find the max of 2 numbers. So let's write a function to find the max of 2 numbers. So we write a function called max AB. And so here our logic would go like this. If A is greater than B, then return A. That's the bigger one. Else return B. And this is the end of the if statement. And this is the end of the function. Now in this case, so if A happens to be bigger than B, then max would be A. If it's less than or equal to B, the max would be B. Now we do not care if A equals B because we can return B since A and B are the same. The max of the 2 numbers, if they are the same, will be the same number. Now how do we use that to write another function called max of 3? And in this case we have 3 numbers that we provide as arguments. So what I'm going to do is I'm going to use the max of 2 to find the max of 3. So let's do it this way. First of all, I'm going to find the, so let's call this M or maxi, because I don't want to confuse that with the function name max. So I'm going to find the maxi would be the max of A and B. Now, once I get the maxi, then I can send maxi to max and send the other one. So now I'm comparing maxi with C, and we can call this the new maxi. And at the end of this, I'm just going to return maxi. And this is the end. Now, how do we know these functions are correct? So let's check to make sure that this function is correct. If you try to find max of 0 and 2, it goes in here. 0 is greater than 2 is false, so it returns 2. If you look at the max of -1 and 5, it goes here, and since B is greater than -1, it's going to return 5. If you find the max of -2 and -2, it will go into this block here and return -2 because A and B are the same. So it seems like it's going to be okay. Now how does it work if you have max of 3? Works if you have to find 3 and 7 and 6. You want to find the max of these 3 numbers. So what it does is if you trace this, the maxi becomes the max of the first 2 numbers first, which is this one here. So that happens to be 7. And then when you get to the next statement, it will compare 7 to C, which in this case would be 6. And so it'll try to find the max of 7 and 6, which returns 7. So the maxi, which happens to be 7 at the end, is the one you return. Now you certainly can write this in different ways using multiple nested if-else statements, but I find it very fascinating to write one function and use that function to write other functions. It's a good practice. iteration. So iteration is the process of repeating something based on a condition. As long as the condition is true, it will continue to repeat. If it's true, it will do the loop body and continue to execute the loop body. So for instance, we can write something like this: I equals 1 while I less than or equal to 10 do print I, and then I becomes I plus 2, end of the while loop. Now if you try to trace this while loop, you'll see that I starts from 1, it prints it, and then it increments by 2, goes to 3, prints it, go to 5, prints it. In all cases, it'll go back and check the value of I to make sure it's less than or equal to 10. Go to 7, print it, go to 9, print it, still less than or equal to 10, go to 11. When you go to 11, it does not go into the while loop, so it doesn't print 11, and therefore your final answer is going to be an output that contains 1, 3, 5, 7, 9. While and for loops. So let's think about this. When you think about a for loop, you think about something like this: for I in 1 to 10 do something with I. Now, so this will be the end. Now the way this loop works is that in a for loop, this is the start index and this is the end index. So the loop starts from the start index and sequentially increment I by 1 until it hits the end index. So essentially this can be expressed as a while loop. So the semantics of this for loop, you can start by saying it starts with the start value, which is 1 in this case, and then it says that keep doing this as long as I is less than or equal to 10. We want to do this for 10 as well. And whatever you want to do with I, you will still do it here. And then one thing you want to make sure is that you're going to increment I by 1 because it is a while loop. So unlike for loops where the I is incremented automatically, in the while loops you have to manually increment I. If you don't do this, I never changes and this loop will become an infinite loop. So do not, this statement is very important. Now one of the flexible things about the while loop is that it doesn't have to be increment by 1. You can increment by 2. You can decrement by 5. So you can do a lot of things to make it work. So this brings us the question of going backwards. So if you want to print something backward, let's say you want to print 10 down to 1. You can start with I equals 10, and then you can say while I is greater than or equal to 1, do print I. And in this case, I'm going to be decrementing, going backwards in I, and this is my end of the while loop. Now if you trace this code, you will notice that you start with the I equals 10, and then you print it, and then the I becomes 9. And you go back to the while loop and check 9 is greater than or equal to 1 is true. So you print it, and then you decrement it by 1. And you keep doing it until you get to 2 and 1. You print all of those things. At some point I will become 0, because when I equals 1 and you subtract 1, it will become 0. If I is 0, you're not going to enter this loop because 0 greater than or equal to 1 is false. And as you recall, you can only enter the while loop if this condition is true. So essentially this print things backwards. Now can we do the same magic with for loops? Unfortunately not. You cannot write a for loop like this for I in 10 down to 1 do. This is illegal because the beginning value is strictly greater than the n value. So you cannot do that. So if you want to do some magic with this, you can say for I in 1 to 10, 1 to 10 do. Let's suppose that I want to still print 10, but I cannot print 10 when I equals 1. So what I can do is I can do a trick here. I can take the 10, subtract I, and add 1 to it. All right, let's see what happens here. So I goes like this. I always go 1, 2, 3, 4 like that in a for loop. So when I equals 1, it will print 10 minus 1 plus 1, which will print 10. When I equals 2, it will print 10 minus 2, which is 9 plus 1. I'm sorry. So we'll get 10 minus 2, that would be 8 plus 1, that would print 9. When I equals 3, you get 10 minus 3, that's 7 plus 1 is 8. Now you get the picture. So I can do the trick to reverse the use of I by doing some trick. Take the max value and subtract I, add 1, and I can do the same thing. It's less trivial than using a while loop. So the next thing I want to do is to come up with a loan payment calculator, but I will do that in my code when I write the code. I want to talk about nested loops a little bit, to semantics of the nested loops. The nested loops work like this. For I in, let's say we have a loop that run from 1 to n, do. And then inside that is a loop that I nest called j. J from 1 to m, do. Notice that it was nested. And then I do some statement here. Okay, and this is the end of this for loop, and this is the end of this for loop. So the way you want to think about the execution of this loop is that you would fix I at 1 first, and then you do the entire internal loop. So the j would run from 1 to m. Then you go back and fix I equals 2. J again run from 1 to m. And I will keep going up down to n, and j would always, for each I, j is going to do it m times. So the total number of times this loop runs, or this statement get executed, is m times n. Okay, by doing that you can do various kinds of magic. We call them ASCII art. For example, suppose you like to draw a skyscraper. So you like to print a skyscraper like this. You want to print something like this. Okay, just to indicate that it is a building. I'm actually looking at, this would be the base. Base is 2 wide, and the height would be 5 stars. So what we essentially have is a building that's of height 5, and the base is 2. So in order to do that, you think about how many rows this thing has. So that's what I'm going to do first. So I'm going to say for I in 1 to 2, do, and then how many columns this has. For j in 1 to 5 columns, do, and then what I'm going to do is I'm going to print a star, and that's the end of for loop. Like I said before, the semantics of the nested loop is that for each I, the j is going to run 5 times in this case. So it's going to print 5 stars with I equals 1, then it's going to print 5 stars with I equals 2. But what I like to do is after you print the first 5 stars, then you must print a new line so you can go to the next line, and this would be the end of it. So notice what happens here. It will print new lines each time you go through I. It will print a star each time you go through j. So this is going to give you this kind of a structure. Obviously, if I can change 2 to m, 5 to n, then I can make it more generic. Now, in terms of using that to create a skyline, all you have to do is once you have the function, you call the function with random size rectangles, and then it'll create the skyline you're looking for. All right, so let's get to the demos next. So this part of the video, I plan to show you how we convert these ideas into actual code. So I like to show you how to draw ASCII art, prime, printing primes, powers of 2, population growth kind of ideas. So we'll do as much as we can. And so the first thing is ASCII art. So let's start with ASCII art. I'm going to start, this window is my input window. So I'm going to call this, I'm going to call it one file. Let's take examples.ruby. Or let's go with this, ASCII.ruby file. So in the ASCII.ruby file, I'm going to define a function called draw rectangle. So to draw a rectangle, I need to have however many rows and however many columns to draw the rectangle. So what I'm going to do is I'm going to write a loop for I in 1, 2 rows do, for j in 1, 2 columns do, and then I will print a star, or we can print an X, doesn't matter. Let's print in a star. Okay, print a star for each j. So this is the end of the j loop. And then before I go back to the I loop, so this means that if I go through the j loop once, I have printed one row, and then I'm going to print a new line so that I can go to the next line and print the next row. So the idea here is that you print that many rows, and for each row that many columns. And so this is the end for that, this for loop here, and then this is the end for the function. Now notice I'm not returning anything because I don't need to return anything, and because I'm printing everything here, and there's no need to return something here. So I'm going to save that, and here I'm going to go to the Ruby interpreter, and then I need to load the ASCII art file, and it says true, so that means it's doing fine. So I call draw rectangle, and let's say I want 2 rows and 4 columns. Columns is kind of like the height. So if I drew that, you can see that you will get the 4 rows and 2 columns. If I say 2 rows and 5 columns, it'll give me this. If I say 3 rows and 5 columns, it'll give me this. So you can definitely create very different type of art using that. So one of the things I like to do is I want to define another function called skyline, which would take take a random rows and random columns. Let's call this R, and C, some random numbers. Actually, it will take random numbers and draw a skyline of 5 things. So in fact, I will do this first. So what I need to do is I want to call the draw rectangle with, I want a skyline of 2 rows and let's take 3 columns, so height 3. And then draw rectangle, I will take 3 and 2, and draw rectangle 4 and 5, and draw rectangle 2 and 7. And this would be the end of it, the function. So what the function will do is it'll call the draw rectangle 4 times, so you will have 4 buildings, with first one being base 2, height 3, base 3, height 2, and so on. So in order to test this function, I need to draw I need to load the file again, and then I want to call now the skyline. So when I call the skyline, no arguments, what it will do is to go here and continue to execute these things and give me, for each one it's going to do this. So this shows you the power of function, because I can reuse this function again and again and again with different values. So in here, if I type skyline, notice that it gave me a skyline. Here's the first rectangle, the second one, and the third one, and the fourth one. So clearly I can do things to make it look nice. So that's my function for doing rectangles. All right, let's take a look at the next one. I want to write a function that checks whether something is prime. So I'm going to go here. We go back to my other window here. Let's close this and start a file called isPrime.ruby. Now define isPrime. Let's call this isPrime here. And you give me an n. I'm going to tell you whether n is prime or not. I'm going to start writing this function. Now, as we know, we check whether something is prime by dividing the number with all numbers from 2 to whatever the prime minus number 1 is 1. But then we will try to improve the code. So let's say we want to write something like this: for I in 2 to n minus 1, do, because we don't want to divide n by n. So now we need to check whether n divided by I is equal to 0. What that means is that if I divides n, then it is not a prime. I starts from 2, then 3, and then 4, and 5. Now, as you know, you don't have to really check. If it doesn't divide by 2, then it doesn't really divide by 4 or 6. So you don't really have to do it, but we don't have much of a choice here in the first round. So we're just going to go with the basic thing. If n mod I is equal to 0, then return false, because we know it is not a prime. Okay, now we don't want to say else return true. That would be incorrect, because what happens is if you say else return true, so if it doesn't, it's not divisible by 3. Let's say you take something like 9. It's not divisible by 2. It will not return false. Then it'll return true. But we know 9 is not a prime number. So you cannot really say to return true if it's not the case, because you got to keep checking. So we end that. So we just use an if, but without an else. But if you go through this loop and you were never able to return false, what that means is the number must be prime. So you return true. Okay, and then, but that's should be the, but before you do that, you have to end the for loop. So I'm going to align this thing a little bit here. So let's just go through the for loop entirely, and you are not able to return false. That means none of these numbers, the i's, did not divide n evenly. So therefore we know it is a prime number. So let's just save it, and then now I'm going to load this isPrime Ruby file, and it's true. So now let's say that I check whether 3 is prime. So let's try that here. Okay, that's so far so good. Let's check whether 4 is prime. That's false. 5 is prime. Well, that's true. 6 is prime. False. 7 is prime. True. And 8 is false. How about 11? How about 19? Well, that's true. How about 21? Well, that's false. So far it seems okay. What about 2? Well, it says true. I think we know 2 is a prime number. What about 1? Well, it says true. We know that 1 is not a prime number. So now we have a problem. So our program doesn't run well if we type 1. Or even if you type something like 0, it says true. If you type something like -3, it says true. So what that means is that we haven't really written a good function here. So we need to go back and make sure that if the number is less than or equal to 1, okay, we want to return we can say no prime, right? So we can actually say return false. So now, since you only do one return, in case you provide anything less than 1, you're going to return false, and you're not going to even look at these guys here. Okay, so let's check that. And now what I'm going to do is I'm going to load this again. Let's go back and load this. Okay, load that. And now we check for 1. That's false. We check for minus sign. That's false. Check for 0. So now we took care of all that stuff. Okay. Now let's go back here and say, okay, can we do better? Well, here we go from 2 to n minus 1. But we don't need to, because we know that you only have to check up to n over 2. Because if the number is greater than n over 2, it cannot divide the number. Okay? So you have to think about that. Like if you take 7, you take 7 over 2. 7 over 2 is going to be 3. But if 3 doesn't divide 7, 4 cannot divide, or 5 cannot divide, because there's no way. You can prove that mathematically. So we save some cycles by just going up to n over 2, not n minus 1. So let's save this again, and then let's load this again and run these things for various numbers. So now I can do this. That's false. And let's try something like that. That's false. And it's very difficult to find larger and larger prime numbers, because it gets very, very hard. In fact, that was a good luck that this number is actually a prime, 768,811. I have no idea, but I'm hoping, because my algorithm is right, that this is a true condition. Okay, so let's go to the next thing that we were going to do. So now that we know how to do one prime, how to check something is a prime, let's do all the primes. So what I'm going to do is I'm going to use this function to write a program that will compute primes between m and n, assuming that m is bigger than n. Okay, so this is why I love loops, because I can now write I from m to n do. Okay, so now because I wrote this function, I could use that function. Okay, so what I can do is I can say if is prime. So for each I coming from this thing, if it's equal to, let's say it's equal to true, okay, then I'm just going to try this and see what happens. So I find the prime, I call this function with this I. So I starts from m plus 1 up to n. If it's true, if it returns true, then I'm going to put print the number that it is, because if it's prime, then I need to know that it is a prime. Okay, and then I'm not going to do anything if it's not, and this is the end of the for loop, and this is the end of the function. Okay, so let's save that and go back to here. Let me exit this and clear this a little bit, and then go back to IRB, and then I'm going to load. Okay, so let's try to load the function name called isPrime.rb. So we load that, and now I'm going to keep my fingers crossed and see if I can find all the primes between 2 and 100. Well, it didn't really give me anything, because the reason may be that this never became true. They were not the same thing. So let's see if I can do something about that. So what I can do is I can, rather than returning false, I'm going to return a number. So if I return 0, that means it's false. If I return 1, that means it's true. So here, when I get the is prime, then I'm going to check whether it's 0. If it's 0, then it's not a prime, but if it's 1, it is a prime. So I'm going to put or print this if it's a prime. So let me give that a try. Now I need to load this again, and I need to print. There we go. Okay, so it seems like it gave me a list of things that looks like primes, but I'm not really sure. But let me go and see whether I can kind of change this so that I can do more than just one at a time. So what I'm going to do is I'm going to print the I to a string, and then I will print a little blank here so that will separate things, and then after I print all of it in the for loop, then I will print a new line so that I keep my output clear. And so here I'm going to go and load this again, and now I'm going to run this primes again. Now there's the prime thing. Let's say I want to find the primes between 200 and 10,000, and it gives me the primes between 200 and 10,000. But if I want to find the primes between 20,000, or actually 200,000 and 1 million, this is 100,000, 1 million, and it does find some primes for me between 200,000 and 1 million. There seems to be a lot of them, but the more and more the distance, you will notice that the distance between them is going to be quite large. It will get larger and larger because it gets harder and harder to find the prime numbers as you proceed. Now let's go back to the next problem while it's doing that calculation. We can do powers of 2 and population growth. I think what I'm going to do is I'm going to stop here, and this is still doing this. You can probably think about how to do those two things.